It looks like about 40% of the people joining us today are from the Midwest, and then we have a good representation from the Northeast, Southeast, and West region as well. Most of the people attending this webinar are joining us by themselves, but we do have a few that are joining us in rooms of between 2 and 5 people, and even one that is 10 and up. So for those of you joining us in big groups, if you wouldn't mind emailing us a list of people who are joining along with their email addresses to info@ruralsafetycenter.org. That way we can provide you with an evaluation survey after the fact. This will allow you to be able to get certificates and potentially even CEUs as well. So if you wouldn't mind, again, sending us a roster to info@ruralsafetycenter.org to make sure we can get you the information you need. Most people are joining us by computer only, about 63%, but we do have about 36% joining us with both the computer and the phone. And we also have a good representation of many different types of transportation organizations. We have the majority coming, or the most, coming from state transportation departments, about 27%, 17% coming from local transportation departments, about 10% from federal, and then we also have a few from tribal governments and a few from other federal and state local agencies. So at this point, we are going to move over to our presentation and get started. So once again, today's webinar is called Systemic Safety Application to a Non-Engineering Concern. And we will have 3 different presenters. Today's duration is from 11 to 12:30 p.m. Mountain Time. We are offering CEUs for this webinar, as I mentioned before. In order to get these CEUs, you'll need to fill out the evaluation survey, which will go out shortly after today's webinar. On that, there will be a box for you to check as to whether or not you'd like to receive CEUs, or if you'd just like to receive a completion certificate. With the CEUs, what will happen then is that you'll be forwarded a PDF form to fill out, and that will go directly to Montana State University's Continuing Education Department. In order to receive these CEUs, you will be required to provide your Social Security number to the university, as you will be put in as a student and receive a transcript. So just so that everyone is aware that that is something that will be needed. The Safety Center will never see that information. It goes directly to the university. Today's webinar is also being recorded. And to ensure that if you're on the phone, please make sure that you turn your computer speakers down all the way. Otherwise, you'll hear feedback. Your phone will be muted for you while the presenters are speaking. But during question and answers, we will explain to you how to open up your microphone so you can ask some questions. Also, another piece of information at the top right of your screen where you're seeing the PowerPoint is 4 arrows pointing out. If you click on that button, it will expand your presentation to full screen mode for easier viewing. And again, at the end of each of these sections, we will have time for question and answer. So today's presenters, we're lucky enough to have Nicole Oneyear and Keith Knapp from the Institute for Transportation, and also a guest speaker, Pat Hoye from Iowa Governor's Traffic Safety Bureau. Nicole Oneyear and Keith Knapp are a part of the Safety Center team. Nicole is a postdoctoral researcher at Institute for Transportation, whose research focuses on rural safety, automated enforcement, and the use of naturalistic driving data. Keith Knapp is a local Technical Assistance Program Director for Iowa. He has more than 25 years of experience in transportation-related training, outreach, and research. His research has focused on safety and operational impacts of roadway design and environmental characteristics. And Pat Hoye, our guest speaker, is a 31-year veteran of the Iowa State Patrol. During his tenure as colonel, the state of Iowa saw record low fatalities and received recognition for the state's high seatbelt compliance and low alcohol-related fatalities. In 2012, Patrick was appointed as the bureau chief of the Governor's Traffic Safety Bureau, where he still serves today. As bureau chief, Patrick and the staff at the Governor's Traffic Safety Bureau have set an aggressive agenda to continue to reduce fatalities and serious injuries in Iowa. And he's going to be talking to you today about one of the programs that they have put into place. And right now I'm going to pass the webinar over to Nicole to get started.
Thanks, Jamie. Welcome, everyone. Our goal for this webinar is that by the end you should have a basic understanding of systemic safety approach, as well as have heard an example of a non-engineering program that incorporates aspects of this project. This goal will be accomplished through 3 main learning outcomes. These learning outcomes include the ability to list characteristics of the systemic safety approach and how it applies to rural safety, recognize the steps of the systemic safety project selection tool, and finally, identify how systemic safety components were used in a non-engineering example. We will revisit these topics periodically throughout our presentation. Our presentation today will cover the 5 following topics. First, why are we focusing on rural safety? Then we'll move into 2 different safety approaches, the traditional hotspot site analysis and the systemic safety approach. We'll then move on to details of the systemic safety project selection tool or selection process using a traditional engineering example. Then I'll hand it over to Pat, who will talk about the Iowa High 5 program, an example of a non-engineering program that incorporates systemic safety, and then we'll hand it over to Keith, who will wrap it up by summarizing how the High 5 program has components of the systemic safety process and some of the must-haves to develop a program yourself. So in this next section, we'll cover our first learning outcome, listing the characteristics of the systemic safety approach. But first, why are we focusing on rural safety? The main reason is that in rural areas, fatal and injury crashes tend to be overrepresented. 19% of the U.S. population lives in rural areas, yet 54% of all fatal crashes occur in these areas. Additionally, the fatality rate in rural areas is about twice that when compared to looking at urban areas. Additionally, a larger percentage of rural drivers die at the scene or en route to the hospital compared to urban drivers. There's 2 main contributing factors to this. The first, the reason we have a lot of fatal and injury crashes is because crashes in rural areas tend to be at higher speeds, so they are more severe. The larger percentage die at the scene or en route to the hospital, generally due to slower response times for EMS. It takes them longer to get the EMS to get to the crash location and start administering life-saving procedures, and then even longer to get them to a Trauma 1 center. As one can see, rural roads are an area for safety investment improvement. Sites for safety improvements have been traditionally determined using hotspot site analysis. With hotspot site analysis, one would pick locations within our jurisdiction and find the area, or we would pick locations that have high crashes or high crash rates, and then put investments in those specific areas. So if you look at this little picture in the corner, we would put our safety improvements in this center intersection that has a high amount of crashes and not as much in the outlying because their crashes and crash rates are smaller. Hotspot approach works very well to identify critical areas for safety improvements at specific locations. However, it is not always appropriate for rural areas due to the smaller densities of crashes as they're more widespread, which makes it hard to identify high crash locations. Using hotspot analysis only may lead to more improvements in urban areas compared to rural areas as crashes are more dense there. A new method has been emphasized in recent years, which may be more appropriate for rural areas. This is systemic safety. Systemic safety analysis is a complementary analysis to the hotspot, which evaluates the entire system based on the risk of crashes. The risk of crashes on a roadway is determined by taking aggregate crash history and determining those characteristics which are most at risk for crashes. What this means is you would look at all of the crashes across your entire jurisdiction or state and determine which types of crashes are most common, specifically looking at fatal and severe crashes. So then you'll choose those to focus on and try to identify what roadway characteristics are most common in these crashes. Not necessarily what roadway features contributed to the crash, but what are present at the location of the crash. So for instance, most states, if you look at their aggregate crash data, you would find that run-off-the-road crashes are one of the most common. And then to identify risk factors, you look at the roadway features. So you may find that curves, having no shoulder, and narrow lanes all increase your risk of a run off the road. So those would be your risk factors. Sites are then evaluated based on these risks, and improvement locations are determined. Systemic safety improvements are more proactive and involve utilizing low-cost countermeasures over the entire at-risk system. So to summarize, the main differences between hotspot analysis and systemic safety analysis are that hotspot tends to be more reactive. You look at where the crashes have already occurred and put your improvements in those locations. While systemic tends to be more proactive, you look at where the risk for crashes is and you'll put your investments in those locations. With the hotspot approach, if there's no crashes but a risk, you would consider there to be no risk because they only assume risk where crashes have already occurred. Well, with systemic, that's not the case. If there's no crashes but a risk, you would still assume there's a risk for potential crashes to occur. Additionally, the hotspot approach uses site-specific crashes, while the systemic approach uses aggregate crashes and determines surrogates or risk factors that contribute to those crashes. These two approaches, while different, work very well together. It is highly recommended that you use a balance of these two in order to have a comprehensive safety plan. So you don't want to focus completely on hotspot and you don't want to focus completely on systemic, as they both have their merits. Now that we understand the basis behind the systemic safety approach, does anyone have any questions?
And to direct your questions to Nicole, you can either type them into the chat pod on the left side of your screen. Once we have those questions, I'll read them out loud to Nicole. The other option you have is to ask them by phone. You can unmute your phone by pressing star and then the pound keys. This will place you in a queue, and when it's your turn, you will receive a prompt over the phone saying your microphone has been turned on. Once you hear that prompt, you're able to speak and be heard by Nicole.
The floor mode is on. To request the floor, enter star, then pound.
And while we're waiting to see if there are any questions both by the phone and by the chat pod, we do have a poll question for you. Which of the characteristics below is associated with the systemic safety approach? You can select all that apply. The options are widespread implementation of low-cost countermeasures. It is a reactive approach. It uses aggregate crashes to identify high-risk roadway characteristics, works with low densities of crashes, and improvement locations are identified using only crash data and not risk factors. We'll give everyone a few minutes to fill in the poll questions, and it does look like we have some questions coming in through the chat pod as well. Okay, at this point it looks like, Nicole, everyone has completed the poll, so I'm going to broadcast the results for you so you can speak about those. The one thing before that is a question. How are cost-benefit analysis conducted on a systemic project and compared to a hotspot project?
Hi, Rudy. Welcome. Thanks for the question. This is Keith Knapp, sorry, from Intrans. That is a good question and something that is addressed somewhat in the tool, but it's also something that people are still continuing to investigate. People are with the evaluation, and she'll get into the steps of the systemic safety and the systemic safety process, which has an evaluation at the end. That is actually, I think there's an NCHRP project on it right now looking into better ways of evaluating systemic safety approaches and programs and their impacts. So I guess the correct answer that would be much shorter would be stay tuned. It looks like they're looking into it. But it's a really good question.
And thank you, Rudy, for that question, and Keith for the answer. Nicole, would you like to address the poll question?
Okay, thanks, Jamie. So it looks like for the most part, everyone got the poll question correct. The correct answers were A, C, and D. B was incorrect, or the second one, because it is not a reactive approach. That would be the hotspot analysis. Systemic safety is more proactive. You look at where the risk for crashes is, not where crashes have already occurred. And no one chose the last one. Improvement locations are identified using only crash data, not risk factors. That would be the hotspot approach again, and not systemic.
Floor request mode has ended.
All right, so now we'll move on to going over our second learning outcome. So by the end of this section, you should recognize the steps of the Systemic Safety Project Selection process. The Systemic Safety Project Selection tool was developed by Federal Highway in 2013, and it helps to better define at the national level the systemic selection process. This is a tool this tool is more a process than a tool, and is meant to be flexible and able to fit the data you have available. The more data you have, however, the better results there will be. The developed tool is a cyclical process which involves 6 main steps. These 6 steps are broken into 3 main components. The first is the systemic planning process, which is shown here in blue, the first 4 circles. It provides instructions to identify and prioritize systemic safety improvement projects. The second element of the tool presents a mechanism for agencies to determine the appropriate balance of funding between the hotspot site approach analysis and the systemic project shown here in green. So what we talked about earlier, that you want to have a balance, so this step helps you with that. And lastly, the tool presents a mechanism to evaluate how your program is doing. So we'll focus mainly on the systemic planning process, the blue part, but we'll highlight the final 2 components at the end. As you can see, the planning process has 4 main steps. The first step is to identify focus crash types and risk factors. This can be done by looking at crash data for your state or jurisdiction and identifying the most common crash types, and then determining overrepresented or common factors, such as roadway features, correlated with those crash types. So as I mentioned before, this would be looking at all your crashes across the state, and as I used the example before, finding run-off-the-road crashes, and then determining that run-off-the-road crashes potentially in rural areas especially, and then identifying those risk factors, so the curves, the narrow lanes, the no shoulders. If you don't have the crash data, the process is flexible, as we mentioned earlier, and you could instead use your state's focus crash types identified in their strategic highway safety plan. In step 2, one would determine the locations that would be of highest risk for the crash type determined in step 1. So as we mentioned before, run-off-the-road crashes, you would look at all the potential roadways in your rural areas and use our risk factors and determine which are more at risk compared to others. A basic prioritization process weighing the risks of the type of crash happening on each roadway would then be used to end up with your prioritized list of locations. Once locations have been prioritized, we move on to step 3, where low-cost countermeasures would be selected. When selecting countermeasures, you make sure that they address the crash type selected and the factors present. Finally, in step 4, a decision-making process for determining when each countermeasure should be applied would be developed and then used to select the appropriate countermeasure or countermeasures for each prioritized site, resulting in a long list of prioritized safety projects. So I went through that kind of fast. It was just a general overview, but now we'll go over an engineering example of how this process may play out. So with step 1, as we mentioned earlier, we identify first our focus crash type. One method to accomplish this is to map out our crashes similar to this method shown here. I'm not sure if you'll be able to read this, but it's just to show you the basic process. For this, you would break out your crashes in various ways. In this case, it's broken down by infrastructure, so we have first the type of roadway it is, if it's urban or rural, and then if it's intersection related or not, if it's on a curve or not, and all of it's broken down by that. And once you have it broken down, you'd find your most common crash types and select either one as a focused crash type, or if you want to address multiple, select the ones that are most common as multiple focus types. As we mentioned earlier, if you do not have crash data available to complete this process, you could use other data. You could use citation data. You could choose a crash type identified in your state strategic highway safety plan or the AASHTO strategic highway safety plan. For our example, we will say that looking at crashes, we found that rural unsignalized crashes are overrepresented and they will be our focus crash type, or more specifically, right-angle crashes at unsignalized rural intersections. We then need to determine the risk factors present in these crashes. Our risk factors that we have identified include entering ADT, if the intersection is on a skew angle or not, if it's located in or near a horizontal curve, if there's lighting present or not, and if fatal and injury crashes have occurred there. These can be identified by identifying previous crashes using the same process as shown in the slide before by mapping it out, whether common roadway features are present or not. Then looking at the tree, one would identify which factors are most common or overrepresented. Additional ways of determining risk factors if you do not have crash data include looking at documents such as the known factors from the Highway Safety Manual, previous research, anecdotal data, crash modification factors, as well as the Systemic Safety Project Selection Tool also has a list of some known factors. Now that we know our risk factors, we'll need to prioritize our locations. For this step, we'll first identify all of our rule unsignalized intersections in our jurisdiction. Then we'll use a weighted scoring system to rank our sites based on the 5 risk factors we had identified in the previous step. Below is an example of a simple, evenly weighted scoring system. So for this, you would, if the factor is present, you would give it a star. If it's not, they get no star. And then you'll total them all up, as you see on the right, and then rank them from the most stars to the least stars. And the most stars are your more prioritized projects, as they have more risk factors present. If you want, however, to put more emphasis on one of your risk factors, if you feel that it contributes more to potential crashes, or if you're more confident in the data available, you could put more weight on that. So for instance, if you're more confident that in or near curves increases your crash rates than everything else, you could put 2 stars on that. So then A and C would both go up to be 7 and 5 total stars, while B would still stay the same because in or near a curve is not present. Sources for determining the presence of these risk factors at your sites could include looking at aerial photos that you may have, or Google Earth. You could look at video logs, traffic counts, as well as other internal databases you may have on your assets. Once you have your sites prioritized, you then need to determine the appropriate countermeasures. So in step 3, we'll select our countermeasures. In our case, we chose 3 commonly used countermeasures for rural intersections that help reduce right-angle crashes. So we chose adding lighting if it's not present, installing transverse rumble strips at the approach to the intersection, and using on-pavement signing. Sources of countermeasures include Federal Highway Proven Countermeasures, the Crash Modification Factor Clearinghouse, the NCHRP 500 series, other research, or jurisdictional experience, policy, or practice. Make sure when selecting a countermeasure that it targets your focus crash types. One also needs to take into account the cost, not only the installation cost, but also the maintenance cost, and the effectiveness when determining which countermeasures you should select. A benefit cost analysis might be helpful in determining which countermeasures are better investments.
So that is also where, in response to Rudy's question.
You can also do benefit costs before installing the countermeasure at a site, and using things like the Crash Modification Factor Clearinghouse data to help with that. Once you've selected your countermeasures, you then need to prioritize your project. So we have a list of all of our prioritized sites and our list of our countermeasures. So first thing you need to do is create a decision process for your countermeasure selection. So for in our instance, we have transverse rumble strips as one of our countermeasures. Those you might not want to install in noise-sensitive areas, so you might choose another countermeasure. Another example in this case would be if your intersection already has lighting, you wouldn't want to install it again. So you would want to choose one of the other countermeasures. We would apply a decision tree similar to the one shown here, which again you probably can't read, but just shows the basic process where you'd have yes or no questions for the most part, and you'd have 1 or 2 answers that would help you break down to determine the best countermeasure or countermeasures for your site. Once we have the process developed, you would then use the criteria and determine the most appropriate countermeasure for each site we had in step 2, along with the cost associated with each. So after this step, you'll have a large list of potential projects and costs. Now to determine which project should be implemented in what order, you'll have to go through and look at a variety of things, besides just our earlier prioritization ranking. So other factors that play a role could include funding availability, time to develop plans if you have to change any of the intersection, if it can be done in conjunction with other already programmed projects. So for instance, if you're going to be repaving a road in 6 months, you don't want to put on-pavement signing down now. You would want to do it in conjunction with that repaving. Additionally, one might take into account nearby improvements. So for instance, if you were installing chevrons on curves, 2 curves near each other but with another curve in between, you would probably just install them at all 3 as they'll already be out there. Now that we've gone through the planning process and the systemic safety selection tool, so the first 4 steps, the blue part shown in the cyclical process earlier, we'll now move on to those last 2 steps. These steps include identifying funding for systemic programs and implementing, and then finally program evaluation. So in identifying funding, again, you need to make sure you balance your hotspot investments, site investments, along with your systemic investments, as they each have their merits in identifying areas for safety improvement. Potential funding sources may include writing grants, using your state safety improvement funds, or incorporating it into your capital budget. This step will help to determine the number of projects that will be able to be completed. So then once you have your funding available, you'll start implementing, where you'll actually put the countermeasures into place at the sites you had identified. Following that, you'll have implemented. You then need to evaluate your program to determine if it's being effective, and if not, areas you could improve. There are 3 levels of program evaluation listed in the tool. The first is output. This could be just counting the number of sites you've implemented your countermeasures at. Then there's countermeasure performance. So for instance, installing lighting, you would want to increase the stopping when people start reacting to the intersection at night. So you may try to find the average breaking point, or the average point where people start reacting before you install the lighting and after. And then the final type is looking at crash types. This will take the longest to evaluate, as you need adequate after data to be able to successfully run a crash analysis. And when running these crash analyses, you generally don't look at just the sites you implemented, but look at your aggregate crashes across your whole jurisdiction before you implement it and after, and see how it's affected there. So to summarize, systemic safety analysis, the systemic safety approach uses widely implemented improvements based on high-risk roadway features correlated with particular severe crash types. So to put it more simply, we find our most common crash type across our jurisdiction, find the roadway characteristics commonly present at these crashes, and then widely implement countermeasures which address these crashes at sites identified and prioritized using the risk factors determined. Again, this is a complementary analysis to hotspot site approach and should be used together to have a comprehensive safety plan. The Systemic Safety Project Selection Tool is a flexible 6-step process for selecting systemic safety projects for your program. It was developed by Federal Highway in 2013. We walked through the project using a traditional engineering example. A link to the document is listed if you'd like to read through it in more detail. It also provides more step-by-step instructions. So overall, this was just a brief overview of the process. More information on the process is online at the Federal Highway Systemic Safety website managed by Karen Scurry. The link to that is we unfortunately didn't put it up. It's the first part of the link to the project tool. If you just take out the FHWA SA 13019, it'll take you to the site. On the website, you'll find more resources, including examples, as well as previous webinars given on systemic safety, as well as some more summary documents. So does anyone have any questions of rural safety or the systemic process?
Thank you, Nicole. So once again, you can direct your questions via the chat pod on the left-hand side of your screen, or you can ask them via the phone. And to do so, again, press star and pound. This will place you in a queue. You will receive a prompt on your phone saying your microphone has been turned on when it is your turn to speak. And at that time, please state your name and organization and then ask your question of Nicole. We do have another poll question to go to for this section as well, but before I do that, we had the question from Rudy about benefit cost, and we did have an answer come in over the chat pod from FHWA as well that I wanted to read off. So benefit costs can be done easily by using an example, and two were provided to us. If you have $500,000 with the systemic safety approach, you might be able to improve the safety of 5 intersections with things such as turn lanes, oversized signs, doubling up on signs. But with the reactive or hotspot approach, you might only be able to improve 1 intersection. Or if you use a curve as an example, if you have $20,000, you might be able to add curve signs at 4 high-risk curves, whereas at the hotspot, you might only be able to re-engineer 1 curve itself. So that's another way to look at the benefit costs as well. So
The floor mode is on. To request the floor, enter star, then pound.
While we're waiting to see if there are any questions, our next poll question for you is, of the steps listed below, which is not one of the 6 steps in the systemic safety project selection process? And the ones provided are screen and prioritize candidate locations, select countermeasures, perform systemic program evaluation, identify high crash locations, identify funding for systemic program and implementation. We do have a question that came in over the chat pod. It says, I am confused by the non-engineering part of this presentation. Will non-engineering approaches be discussed, or will this be addressed to non-engineers?
Right. John, this is Keith. We're going to talk about the GTSB program next, and then I'm going to try to connect the two. And what's going to come up here is essentially connecting the two, the systemic safety approach. She used an engineering example because that's typically what is done. And then he's going to talk about the program, and I'm going to connect the two. They were actually developed in parallel to each other. So they incorporated some of the aspects of systemic safety that I'm going to identify and talk a little bit about how behavioral stuff often does rise to the top, that we need to come up with an approach to apply in the systemic safety area. So I hope that's what you're looking for.
Okay, and at this time it looks like we are done with the poll, so I'm going to end that and broadcast the results. Nicole, if you'd like to address those.
So our correct answer for this one is D, identify high crash locations. You wouldn't identify specific high crash locations in this. You would identify your aggregate crashes and find your high crash types, not locations. Identifying funding for a systemic safety program and implement is part of the systemic project selection process. It's not part of the planning process, those first 4 steps. But overall, it seems like people were able to grasp that. All right, so now you'll hear about the Iowa GTSB High 5 program. High 5, as Keith mentioned, was developed around the same time as the selection tool was being developed and focuses on fatality reduction in rural areas and had a multidisciplinary approach to safety improvement. It contains aspects of systemic safety without them knowing it, and is a great example of applying some components of systemic safety to address a non-engineering concern. Now I'll pass it over to Pat Hoye to describe the program in more detail as it was set up and applied. After, Keith will connect their program to the systemic safety process described previously and give some lessons learned to help develop a similar program.
Thanks, Nicole. Our bureau, the GTSB, is the Governor's Traffic Safety Bureau. We were looking for a new and innovative program that could reduce fatality and serious injury crashes. We knew it needed to be a comprehensive plan involving many of our safety partners and that would focus on proven methods that we knew could be successful. As the planning for the project began to take shape, it was obvious that after reviewing 5 years of crash data, that the project needed to have a strong emphasis in 2 areas, rural roads and seatbelt compliance. With the 93% compliance rate, you would think belt use would not be a problem in Iowa, but it is. The number of unrestrained fatalities were extraordinarily high and not acceptable, and fatalities were occurring well over 70% on our rural roads. Another disturbing trend was the discrepancy between high seatbelt use in our cities and the low rate in rural Iowa, with some of our counties reporting as low as 60% for seatbelt compliance. What is the High Five Rural Traffic Safety Project? In a nutshell, the High Five Rural Traffic Safety Project was where we selected 5 rural Iowa counties that had higher than expected crash rates and low seatbelt compliance rates. We saw those two as being essential to the program, that if we could address counties that were having higher than normal rates and yet had low seatbelt compliance, so we looked at all of the counties in Iowa, and that's how we selected these 5. There's a lot of things that you can focus: speed, impaired driving, so why focus on belt use? Well, in our Bureau, we believe that wearing a seatbelt increases your chances of surviving a crash by 45%. How many times have you read in your local paper the subject was ejected and died at the scene? That doesn't happen when the subjects are properly belted in. Remember, Iowa has a 93% seatbelt compliance rate, yet 42% of our fatalities are unbuckled. We found that to be unacceptable. It's no coincidence that as belt use goes up, fatalities go down. It happened here in Iowa, and no matter what state you are in, I'm sure that you have seen this same pattern. So if we can continue to get seatbelt use to go up, that fatalities will continue to come down. The map that you're seeing there, the yellow counties represent the 5 original High Five projects, and they were selected because they give us a good snapshot of counties, rural counties across the state of Iowa. The High Five project focused really on 3 main areas: enforcement, engineering, and education. We felt that if we could coordinate these 3 areas, our project would have a strong chance of success. We set up informal meetings with the county sheriff and the county engineer and the local district commander from the State Patrol and the State Patrol's safety education officers. Our staff and the DOT engineers facilitated these meetings. We laid out our expectations, funding opportunities for overtime, and engineering costs that each county would be able to receive, and also the requirements that they would need to do. We selected 11 counties to start with the program, thinking that we would need 11 counties to whittle down to find 5 that would be willing to accept it. But fortunately, the very first 5 counties that we went to jumped on board with our project. It was important to set guidelines and what was expected from our agencies and what the outcomes would be. From our sheriffs, we needed them to conduct seatbelt compliance checks before the project started, and then again halfway through the project and at the conclusion. The State Patrol safety education officers were required to do 12 media contacts, such as letters to the editors, and explain why the High Five was in their county, and also to do school visits. The good thing here in Iowa that in a rural community or county, the odds are that there is only one high school. Monthly activity reports were required to track the activity, and it was our belief that a strong enforcement effort would drive up compliance rates. And lastly, we worked with the county engineers to work with our state DOT and assessments team to conduct road safety audits in the counties. If crashes are happening due to engineering design, no matter how much enforcement you do, you will not see dramatic reductions in crashes. Our goals were really pretty simple. We wanted to reduce crashes, we wanted to increase seatbelt use, and make some long-lasting roadway improvements. We created an activity report so our office could track monthly how the project was progressing. We actually had one sheriff call towards the end of the project and say that his activity for the month wasn't reflective of their efforts. He said it was just getting harder to find anyone not wearing a seatbelt. And truly, that's what we were hoping to see in this project. The road safety audits were successful in identifying low-cost projects that could be addressed from dangerous curves to widening of shoulders on a road. All of our projects saw some type of improvement in these 5 counties. One successful educational piece was when the patrol attended the county fairs and pushed out high five information. We had educational cards made, and they talked about why the high five project was so important and why wearing your seatbelt could save your life. The other thing that obviously was going to be a large part of this was high visibility enforcement. Counties that rarely saw more than one enforcement vehicle a day were now seeing heavy law enforcement presence and joint projects that were being conducted with the sheriff's office and the state patrol. Some of the initial seatbelt surveys showed that there was a lot of work to be done. If you can see on the very first one, Alameda County, their first compliance check showed that only 60% of the residents were buckled up. 18 months later, the compliance rate had climbed to 76%. Even counties that had respectable percentages like Marion County went from a start of 90% and climbed to 97%. Our law enforcement partners stepped up their efforts, and it worked. Palo Alto County in 2013 had issued 52 seatbelt citations for the year, and 1 year later, they had issued 143 citations. Remember, these are small counties in Iowa, and to see those kind of increases really showed that, that law enforcement had taken this project to heart. Finally, the most telling stat was the decline in overall crashes by almost 7%. Iowa as a whole in 2014 saw a slight increase in fatalities and crashes, yet these 5 counties that were selected in part because of high crash rates saw a 7% decrease. Seatbelts really do make a difference. Our program manager who helped create and oversee the High Five project was a police officer before he joined the Governor's Traffic Safety Bureau and was involved in this crash. He credits his seatbelt use from keeping him from being seriously injured. We kidded him about if he was truly a good cop, he'd avoided the crash altogether, but that's another story for another time.
All right.
Okay.
So now we'll see if anyone has any questions for Pat.
And once again, if you have some questions, you can put them into the chat pod on the left-hand side. You can also press the star and pound keys to activate the phone. Pat, one question that we do have for you while we're waiting to see if others have some is Iowa has a primary seatbelt law, so it's easier to do. What would you do if it had a secondary seatbelt law?
And that is certainly a concern because, you know, in Iowa, part of the reason for the success was it was a primary and law enforcement can address it. But what we have seen around the country is even states with secondary enforcement, that high visibility in itself is a deterrent and will get people to buckle up. So by seeing traffic stops for speed, other things, we have found that people will put on a seatbelt when they see the flashing red lights and if they're seeing a heavy law enforcement presence out there. And also, one of the things that we're encouraging secondary states to do is you can still write seatbelt citations, you just have to find another violation first. You know, so when you're stopping vehicles for speed, no taillights, things like that, that opens up the opportunity to address the seatbelt.
Thank you, Pat. We also had one other question come in for the chat pod for you. Did the program affect other violations like DWI and speeding citations and crashes?
You know, it did. The emphasis was on seatbelts because we believe that there's a direct correlation of seatbelt use versus reduction in crashes and serious injury and fatality crashes. But because these small counties, there was such a large presence of law enforcement, we actually did see the number of impaired driving arrests spike, and the number of the number one violation that was actually addressed was speeding. So it did have a comprehensive effect on all violations, even though the emphasis of the program is on seatbelt use.
Okay, thank you, Pat. It looks like that is the last of our questions for you at this time.
All right. So thanks, Pat. Now I'll hand it over to Keith, who will go over how High Five incorporated systemic safety components, which addresses our last learning outcome.
Thank you, Nicole, and thanks, Pat. So what you've heard so far today is essentially a discussion about systemic safety, its characteristics, and again the tool and the steps. And Nicole actually mentioned again that one of the big things with the systemic safety approach is it does have flexibility to it. And what had happened, essentially, what I'd like to do essentially is address this last learning outcome, which is identifying how some of the systemic safety components, some of those bubbles, if you will, in the 6-step cycle were used in High Five. Now, they didn't do it on purpose because what was happening, of course, was, I'll just advance the slide here. Sorry.
Okay,
Thank you. Is that the systemic safety approach was being defined, the tool was being written while the High Five program was also being developed. So they didn't have the book, if you will, the tool to exactly follow while it was happening. But what was occurring, of course, is our neighbors to the north, Minnesota, had also applied systemic safety at their county level. We were talking about it, certainly, and I do remember presenting presenting systemic safety and what was going on in different states to the fellow that developed the High Five program. So I'm gonna say it was serendipity, and he absorbed some of that. But we also have similar objectives, similar goals. So they're addressing similar issues. There's a widespread issue of unbelted fatalities in rural areas that needed to be reduced, and that's why systemic safety was set up. In addition, here in Minnesota, in Iowa, we have a really long tradition of the disciplines working together. So that wasn't surprising, again, that we had both engineering and enforcement and education talking together to bring it all together. So what I'm going to try to do essentially in the next slide is show you that of those 6 components in systemic safety, in a different type of context, the behavioral context, that they did apply. So what did they do? Well, they used crash data. They looked at the state, made a determination that unbelted was an issue, or I should say, it made a difference that unbelted rural fatalities were an issue, and they were mostly single vehicle crashes. So this is a widespread safety issue. There's a number of different crash types, of course, that have the unbelted problem in rural areas, and that will come into it a little bit when we get into our road safety audits and the data we looked at there. So they identified a crash type, if you will, and the risk factor was unbelted, and that is a behavioral decision that was the risk factor for a lot of different rural crashes. So there's a behavioral part to that and an infrastructural part to that. The behavioral part is, of course, we want more people to wear seatbelts. So we're going to reduce fatalities, reduce severe injury crashes. The infrastructural part is keeping people on the roadway. So while roadway departure crashes, let's say, rises to the top in rural crash analysis, the unbelted is still an issue with roadway departures. So you can approach this problem from 2 different directions. In fact, it might work better if we did do that in all cases. What that let them do was essentially identify that there was a problem. So we got these 6 steps, and that covers a couple of those. They then looked at seatbelt surveys, a different type of data, to actually prioritize and screen to the county level. Because what you'll notice if you look down at the next bullet is there was county-wide applications, the increased enforcement, the increased education, and then there was the road safety audits that we did that were at the engineering level. So they used seatbelt surveys to screen to the county level. We then looked at within those counties, we looked at crash data to screen to locations that we wanted to look at. We also, I'll be honest with you, I was on one of those teams in one of the counties. We also talked to the county engineer and the sheriff and said, hey, what are the issues you're dealing with? And where are those locations? So we screened and prioritized based on crash data at the county level to actually identify locations for our engineering road safety audit, more specific site location, if you will, focus. And we got a multidisciplinary team together in each of these locations, county engineer, sheriff, we had several people. LTAP was involved and a couple others in each one of these, and we produced an assessment report that had to do with infrastructure countermeasures that we suggested. Lastly, again, we had these multidisciplinary approaches, enforcement, education, and engineering. As I mentioned, some of them were county-wide, and some of them would be what I would call locational. In fact, at the county that I was involved with, we focused on roadway departure issues. And so, again, the idea being keep people on the road, seatbelt or not, it's a good thing, and also improve seatbelt use. The last few steps, if you will, in the systemic safety cycle, the funding and the implementing. Funding came from GTSB. The NHTSA people helped with the education and the enforcement. I talked to the county engineer while we were doing our roadway assessment. Every intent was to ask for some HSIP money to do some engineering improvements, so different funding approaches again. And then the evaluation. They made it really clear that one of the big things for them with the program was evaluating it through different types of data. We had citation improvements. We had seatbelt surveys. We also did media contacts, I think was one of them. So we had several different types of evaluative measures to determine if the program was doing well or not. So we had 6 steps in the systemic safety loop, and I'm going to try to remember them by memory. Oh, actually, I got the list. Sorry. Identifying crash types and risk factors, right? So we got unbelted, we got a certain type of crash, and unbelted combined. Screen and prioritize locations. We screened and prioritized counties, and then we screened and prioritized at the county level down for the engineering and infrastructure improvement level. Selection of countermeasures. Pat talked about the countermeasures were enforcement, education, and then the engineering improvements we've suggested. And then, of course, identifying funding. We just talked about that, and evaluation. So I'm going to step out on a limb and say they did 4 or 5 of the 6 steps of the systemic safety cycle, looked at, again, from a different context. And if we can go to the next slide here, here's some of the lessons we learned, which we'll talk about a little bit here. You really do, when these things rise to the top as overrepresented types of crashes or things that need to be addressed, I really believe you need a champion to lead this, and we had a champion in Randy Honenfeld. We still have champions leading this program. This is a good, effective program, and if you have a multidisciplinary issue, it's really good to have multidisciplinary applications. But you do need to get buy-in from all these groups, especially when you're dealing in a rural, local situation. You have to have buy-in from enforcement and the people that are on the ground, enforcement and engineering that are on the ground that see this as a positive thing. Because as, again, you get down to those levels, if you just come in and ask them to do it, it's not always as good. They need to be on board. They need to be vested. You also want to evaluate your program and show that it's working and fix any problems that are happening. And, of course, wrap it all back and link it to your priorities, link your funding to your priorities, have your plans developed. Now when we're having our local road safety plans being developed here in Iowa and things like that, we might take a slightly different approach to all this. Maybe a little more specific with this slide, the road safety audit and what have you. We might look at more risk factors because now we've evaluated that data. So there's certainly ways of improving the steps that we've gone through. I actually will just take any questions now, but that's the connection to systemic safety. I hope that was clear for everybody. If anybody's got any questions, I'm open to those.
Thank you, Keith. And once again, on the left-hand side, you can use the chat pod to type in your questions, or you can hit star and pound to be put into a queue to speak on the phone. It looks like we do have a few questions coming in. One that we already had was for Pat Hoye, and it is, what percentage was the enforcement increase to achieve the high visibility enforcement?
There were every county. The only law enforcement statistic that we tracked was seatbelt citations. That was the outcome that we tracked. I think we had a high of a 217% increase in one county in citations, and the other was, I believe, the minimum was about 20%. So we saw significant jumps in that countermeasure of seatbelt citations. Overall, the activity, we did not track that as a goal, but we did see a significant jump in really all enforcement levels there.
Yeah, and the buy-in that they got before they went to these counties helped, because of course the sheriff and everybody was on board and was telling the staff, focus on this.
Yeah. And that was one of the things that on the educational piece that really helped too is as the program started that very first month, we sent out letters to the editor to every paper in that county, and once again these were small counties, and it was one or two papers, but they are eager to grab any articles like that for a small paper. And in those letters to the editor, we talked about the goal of the high five. Although you would see stepped up enforcement, at the end of the day, it's about reducing crashes. And the reason that your county was identified was because you're having high crash rates and you're having a low seatbelt compliance. So it was really all safety based, and we supported, from the Governor's Traffic Safety Bureau, we supported the sheriffs for being safety advocates for taking on this project in their county.
Thank you, Pat. At this time, we're going to go to a poll question as well. I know there are a few other questions coming in. The last poll question for you guys is identify which of the systemic safety components below were used in the non-engineering example. While everyone is taking some time to do that, one other question for you, Pat, is what was your level of investment and what specifically did you fund?
We, and actually, that's why it turned out to be the high five and not the high 10 or 12, was it was truly what we felt we could fund. We felt that we had a cap of $100,000 that we set aside for this project, and that was going to be used to pay for overtime and for any incidentals that would come up, educational printing, things like that. So what we did, we provided the county sheriff's department $10,000 for overtime for the year, and then whatever state patrol district office was in that area, we provided the state patrol with $10,000 that would be used for overtime. At the end, I think our total cost was about $72,000. Some of the overtime just was not used. What we did for engineering costs, that was projects that we worked with a state DOT, and actually was not part of our funding source. So, but it was truly for the amount of money that we invested in the program. We just felt that the results were very gratifying.
And then on the engineering side, it was really, we submitted those reports to the county engineer, and it was really on them to take them forward. And I suppose we could look back and see whether, for those 5, whether they submitted anything to the DOT to get some funding for those infrastructural measures or not.
Thank you, Pat and Keith. We do have one more question that came in. It's for all of the presenters, and FHWA representatives who are also on the webinar. If you have a response that you'd like us to read out for this, you can put them in the chat pod, and I can read read those after our presenters have also answered this question. But the question is, do you have any thoughts on how to fund non-infrastructure systemic safety projects? NHTSA funds never seem to be enough, and it always seems too restrictive, and now HSIP funds can't fund non-infrastructure projects.
Yeah, I agree. NHTSA funds never do seem to be enough. You know, and that's truly probably one of the issues with NHTSA funding is that it truly is supposed to be seed money. So even though that we've gone in and we've done these programs, now it really, for example, those 5 original counties, it does fall on them now to continue the program. We will continue to monitor and work with them, but we've moved on to 5 new counties, and the overtime funding has dried up for those first 5 counties, although we've checked in and they're continuing to do joint projects, the patrol and the sheriff's department, and so we're seeing good results there, but I agree, you know, for large measure projects, you know, NHTSA funding probably is not going to be the correct answer.
Well, and I would think the success of what you found in those first 5 will help them continue, well, it kind of cause them, or, yeah, this thing worked, let's keep doing what we were doing.
Right, and we identified the sheriffs in the county, you know, we reached out through the local papers and such and identified them as, you know, being true pioneers in traffic safety, and, you know, so I think that helps too, that, you know, when you recognize great work, and so I think that helps spur them to continue on with the program.
And the next 5 counties that might show more interest because of what happened.
Right, yeah.
We did have a response from one of our FHWA representatives as well, who did say HSIP funds are used for non-infrastructure projects in some states. So not all states, but in some of them. We have one more question for Pat Hoye that came in as well. Were the educational components limited to handouts and educational officer school presentations? If not, what else was used? And do you have any thoughts on tying a traffic offender program, such as defensive driving courses, to the educational component?
Yeah, that's a great question. And actually, that's what we did. We had multiple school visits, and one of the things that we did with those is we took in driving simulators and through freshman through senior classes, and had breakout groups where the students would go in and do driving. We actually created posters that talked about the high five and put them through, you know, in a local small county, your gas stations, you know, where everybody meets for coffee in the morning. Those are great ones. The other thing that we did, and we tried to get the media outlets, TV stations from that were close to come in and do stories on the high five, and that brought some high attention to the program there. You know, the other thing that was critical was the work with not only the school systems, but we call them animal clubs, the Eagles, the Elks. You know, we were able to go in and in those meetings and you know, talk about why their counties had been selected, and I think at the end of the day, the educational piece probably was as important as the enforcement aspect.
Thank you very much, Pat. We do have some chatter going on in the chat box about whether or not HSIP funds are able to be used for non-infrastructure projects. It appears like they may not be eligible any longer under the FAST Act, but we do have some research going on as to whether or not money appropriated before FAST Act can still be used for non-infrastructure. So there are some questions about that. With FAST Act being a newer act, we may need to do some research to get you guys a definite answer on that one. So Keith, I believe at this point those are the remaining questions that we have. If you'd like to go over this last poll question, I will end it and broadcast the results for you.
Sure. Could we maybe maximize that? So the last question, the answer is all the above, and most everybody answered it that way. They actually did do all 4 of those. So good. Everybody answered well. I appreciate it. So that's about all I have to say, and then I think I've repeated it, that those are the parts of the systemic safety process. Okay. All right. One more last slide. Again, continue to ask questions, chat, what have you. We'll be here. So we had 3 learning outcomes for this webinar. One was to list the characteristics of the systemic safety process. The other one had to do with characteristics of the systemic safety tool. And the other one had to do with identifying the systemic safety components that the High Five program used. And again, I think we were successful in doing that. If anyone has any questions on any of those learning outcomes, absolutely, we're here to answer those. And it's recorded and will be posted.
And here's our contact information if you want to get a hold of any of us to follow up, as well as some more links on systemic safety tool on the Safety Center website, as well as more information on the Safety Center.
So at this point, I want to thank Nicole, Keith, and Pat for taking the time to present at this webinar for us. I also wanted to let everyone know that they will be receiving an evaluation survey later today. And again, if you did want a completion certificate or possibly CEUs, please make sure to fill out that evaluation survey and check those boxes at the very end of it, and we'll send you the appropriate information afterwards. We do have, as the Safety Center, 2 more webinars scheduled as of right now. We have on February 9th from 11 to 12:30 Mountain Time, a Rural Signing and Marking Resources webinar, which the registration is open for right now on our website. We also have another webinar on March 22nd from 9 to 10:30 a.m. Mountain Time on an overview of the factors that increase organization safety culture. That one will be opening for registration next week after the presenters have finalized the information for that webinar. Again, as Nicole and Keith mentioned, this particular webinar has been recorded and will also be archived and available on our website under Training and Archive Trainings. So thank you, everybody, for joining us today. And once again, thank you, Nicole, Keith, and Pat, for the great presentation.